In this section, we're going to look at a few minutes about troubleshooting and troubleshooting tools. The objective is apply troubleshooting methodologies to resolve problems, perform fault isolation, and document, resolve, or escalate, verify, and monitor resolution. So troubleshooting tools, all of the courses that I have done, and there have been several different with different vendors, different books, also talk a little bit about tools in this one. So we're going to look at some troubleshooting tools when we do this. And ARP, Address Resolution Protocol, Ping, TRACEROUTE, and TELNET are tools that we're going to talk about in these topics. ARP, Address Resolution Protocol, is an internet protocol that's used for dynamically mapping IP addresses to MAC addresses. What does that mean? That means that we use it to find the MAC address. The MAC address is going to be local to the device, local on the segment, I guess. I'm going to bring a little demo over here, and we'll look at it and let's talk about this, and we'll talk about it again and again, and it's going to be called when we do address substitution, when we substitute one for the other. When we go from point A to point B, our IP address stays the same, but if I'm going along this route here, what I have to know to get to the next destination is we're going to have the source MAC address is going to be this device, this NIC. The destination MAC address will be here. When we go the next hop, the source MAC address will be here and the destination MAC here. So we're going to substitute MAC addresses, or we're going to change the MAC addresses. And then when we finally get there, this one will be the source and this one will be the destination, so that we use the MAC address to actually locally deliver the packet, the frame. When we go from one to the other, we need the IP addresses, source and destination IP addresses, to find the route to get there. And then we deliver it with the MAC address. To do that, and let me pause, let me get my command prompt up here, and I'll show you on my machine what a MAC table looks like, and then we'll do some things. We'll use a couple of tools here and then go back and look at the ARP table on the router itself. So let me pause here. Okay, I have the command prompt on a Windows machine up. If I type ARP-A on it, I get a whole bunch of stuff here. 192.168.112 is a virtual machine interface. 1.127 is the one interface is what we're actually using. So 192.168.1.1 has a physical address, a MAC address of this, and this is going to be my default gateway. And then I have some other machines that are on this network, and these are going to be their MAC addresses. And you notice these are dynamic, and dynamic means that it changes, they time out, which kind of makes sense, because if we change the IP address, we don't want the MAC address to stay there forever, because then it won't work. If we have two IP addresses with the same MAC address, it just kind of gets weird. Trust me, I've done that with virtual machines. That sometimes it'll communicate, sometimes it won't communicate. So ARP, get this out of the way. ARP is the Internet Protocol to dynamically, where it automatically finds it, and it uses an ARP message, tells me who has this address. A MAC address is the data link layer address of the device. We know that. The MAC address, 48-bit hexadecimal address. The first half is the OUI, the second half the serial number. A mechanism for a host or router to find the MAC address of another host or router when it needs to send packets, and we talked about why it needs that, because the delivery to the device actually happens to the MAC address. The reason that we do that, the hardware address, the reason we do that is IP addresses can change. If we use a protocol, we'll talk about DHCP, which dynamically assigns IP addresses, you may not get the same one, but the MAC address is going to be the same, so it's going to be delivered to it. The source host sends an ARP request message asking for the MAC address, and then the destination provides its MAC address via an ARP reply message. The MAC ARP request is going to be a broadcast message. The ARP reply is going to be a unicast message. The host uses the ARP cache or an ARP host table to store the MAC addresses. The caches vary based on operating system. Windows is, I don't know, 80, 70, 80, 90 seconds. Microsoft uses a 5-minute cache for the ARP table. The next thing we'll talk about connectivity tools, ping, TRACEROUTE, and TELNET. I'll do a couple of them with the little packet tracer demo that I came up with initially, and then probably to show a larger trace I'll use my back to my Windows machine so that we get more. Ping checks for layer 3 connectivity. Am I getting there? ICMP echo request and an ICMP echo reply, one to the other. Ping, and when we go to this device, I'm going to go from this router down here, router 0, to this address up here. The reason is because I wrote the address up here that I can remember it. It is 10.10.20.2. So if I just go into here and ping 10.10.10.20.2, I get success. In Cisco, the exclamation points are good, and typically this is a simulator, so it reacts pretty quickly, but typically on a real device, the first time you're going to get a dot. Dots are not good, and that's because it's doing the ARP lookup. So if I do show IP ARP, let me spread this out a little bit more. The internet 10.10.11.1, age minutes 16, the hardware address, the type gigabit Ethernet 00, and then 11.3. If we look at that 10.10.11.1, 10.10.11.1 is this interface right here. I just did this. If I hover over these in the simulator, it'll tell me what the addressing is on them. If I then want to look at the next one, and I'm going to go ahead and do it, and then we'll look at the slide, is TRACEROUTE. TRACEROUTE, and in Cisco, we'll talk about this. It just came up with the word TRACEROUTE real quick. If you use the tab key, it will complete things for you. So we had what, 10.10.20.2, which will tell me the path that it goes to, the IP addresses of the routers, and then 1, 2, 3 as it goes through them. If we have a failure, the router that it fails at is the one that is going to be where the problem is. So TRACEROUTE finds us the route, and the clever thing, and I'm going to show you or give you the address to get Cisco's Packet Tracer 7.1 from Cisco for real, for free. They're giving it away. They've protected it for a lot of years. This one is kind of already set up, so I'll just go to the auto capture and play. If we go into simulation mode, and I clicked over here on the simulation mode, we can do this. You can see the packets go from point A to point B. And if you want to look at what's inside those packets, you can click on them and it tells you what's there in layers. The inbound BPDU and the outbound PBDU protocol data units. But it shows us, and this one actually was pinging this interface here, so you can see the traffic flow using this particular simulator. So ping and then TRACEROUTE, layer 3 test, and to test the router function. It depends upon an expiring TTL, the time to live. When we create a packet, it has a certain time to live. If it didn't have that, then we'd have packets out there running around forever. They would never expire. So what it does is sets the first TTL to 1. Let's go over here. Didn't really want to do that, did I? It sets the first TTL to 1, and then when the TTL gets to 0, the packet dies. So as TTL 1 gets here, it decrements it to 0, and then we get an error message back. TTL exceeded. Okay, we got there, but we exceeded, so we get the error message back, the ICMP error message back. Time to live, TTL exceeded, time to live exceeded. Then we send 1, we increment it by 1, so we send it with 2 and we get the message back. 3, we get the message back. So TRACEROUTE, a little bit slower typically than ping, and one of the reasons is it tries to resolve the names, or at least Windows tries to resolve the names as it goes from point A to point B. So ping and TRACEROUTE are the two primary tools that we use. Issue with them, layer 3 test. It doesn't tell us that anything's running at the application layer. So yeah, we can ping it, yeah, we can do a TRACEROUTE to it, and then we go HTTP whatever it is and we get nothing. So how can we check to be sure that the application is actually running on that particular device? And that's where TELNET comes in. We can TELNET, and TELNET is typically going to be used to manage one to the other. TELNET is a command line function that would allow us to manage a device at the command line. We can also TELNET to a service port. We could TELNET to an HTTP 80 port, and it would tell us if the service were running there or not. So the way to check to see if a service is working is to use the TELNET command. The other objectives: isolate and document. And over here, the little flow chart: define the problem, gather the facts, consider the possibilities, and create an action plan, implement the action plan, and observe the results. Move this up out of the way. Troubleshooting problems in a network involves identify the correct operation. We got to know what's right before we can find out if what's going wrong, and that's one of the things that we need to do, is to document what goes on our network when it is functioning properly. Examine whether the network is working correctly by checking the documentation and network configuration. Use the Cisco IOS show and debug command, and when we go in order of the objectives, we kind of introduce some things before we actually have done them. Debug is a command used in the Cisco devices, and when you debug, it will tell you everything that's going on, the actions that are going on, what the device, the router, or the switch is actually doing at the time. Isolate, determine the path of the packet in the network and identify the point at which it stops forwarding the packet, and then in TRACEROUTE, wherever it fails to get that error message back is the router that's going to have the issue with it. Use the documentation, network configuration, TRACEROUTE, ping commands. We've got to know where it's supposed to go, how it's supposed to get there. So we can use ping to see if we have connectivity. If we don't, then we can use TRACEROUTE to determine where the route fails, and if the routes are good, we can use a TELNET to see if the application is actually running at the other end. And then the last here is analyze the cause, determine the cause of the problem, and identify suitable actions that can be performed to resolve the problem. And that kind of makes sense. Okay, let's see, it's not working. Where does it fail? Why does it fail? How are we going to fix it? Resolve or escalate. The network diagrams. How the thing is wired. Wiring diagrams are a big deal. They're a pain to do, but they are a big deal to have, because if you don't have them, you don't know what's supposed to be connected to the other one. So network diagrams help resolve the IP connectivity problems, compare the current network traffic with the expected network traffic. Where did we expect it to go, and where is it actually going in these things? Test every hop of the packet from its source to destination to identify the exact issue. One of the procedures, I guess, trying to think of the right word, that we would typically use with ping, if we had a device out here, turn the pen back on, a device out here that had a problem. The first thing we would do is ping our 127.0.0.1, which is the loopback address, the troubleshooting address, see if it works. Then ping the IP address that's on the device. If that all works, ping the default gateway, the IP address of the router. If that works, ping to the other side of the router. If that works, ping the next hop. If that doesn't work, then we've got a route problem. We've got a path problem. So using the procedures, ping yourself. If that works, ping the default gateway. Does that work? And then move on out until you find where the problem is. And again, TRACEROUTE can help an awful lot on these things. Commonly used steps include checking whether the route from the source to the destination is available with the router, and in the show commands it talks about that would be a show IP route. Fixing software problems or configuration problems in a router. The route's not there. We don't have a default gateway or an improper default gateway on the device that's trying to get out of the network. Physical connectivity problems, and over the course of time at the places that I worked, that's been a really big issue. Is something happens because the RJ45s, if they're in there a long time, you get humidity, they get a little bit of corrosion on them. People unplug them, plug them back in, trip over them. Lots of different things can happen to the wires physically. Fixing the physical connectivity problems is a big deal. Check resource availability problems, lack of memory on the router. So is the router got enough horsepower in order to do what we're asking it to do? Routing loops and routing protocol related problems. A routing loop is one, and you can, and I have seen this happen when devices go offline, but we have what's called a default route that says send all of my traffic, and we'll say we have a router here and a router here. Send all of my traffic, and this would be what we would use going out and going to our ISP. And this happened to us with our ISP, except going in. Except that I got a lot of excepts here. We're doing some maintenance one time, and I was checking to be sure that everything had come back up. We had a router out here and a firewall. The firewall was offline. So at the ISP, we had a default route. The default route says sent everything there. So it sent everything here to the router, and the router couldn't find those networks that it was going to. So it's, oh, I've got a default route. I send everything to the ISP. It gets back to the ISP. ISP, and this was the same destination address, which was in here. Said, oh, I'm supposed to send it here. Oh, I don't have it. I've sent everything here. So it just bounced back and forth until when the message was packet expired en route. So that's where the time to live comes in, that when we really want it to go away, that we don't have a packet running around on the internet forever. Identify whether traffic is blocked by firewalls or packet filters, and we're going to do access control as packet filters. Have we stopped that traffic? inadvertently. And then it says in here, in case you are unable to resolve the issues, you need to escalate to the next level or to the Cisco Systems TAC. Cisco will assist you in troubleshooting as long as you have a maintenance contract with them. Network diagrams output the show and the debug commands and key information you gathered while troubleshooting is going to be useful when you do these issues. So take all of your document all your troubleshooting and take all your troubleshooting with you. The debug command, the two most commonly used commands for troubleshooting network problems are show and debug, and I guess we might as well look at those here. I don't think we're going to see a whole lot here, but if we do show and I do a question mark, I get a whole list of things that I can show. Let's show IP route. So this shows me the IP routes, the routes to the different networks that are available to me. So a whole lot of show commands. Debug, and we can debug specifics or debug all. Let's see, debug. It's got to be in a different mode. When you mess up, Cisco will tell you where you messed up. That's the caret. Actually, no, it's not. It's debug IP all, I think. Debug IP all. Debug IP, well, routing that. Okay, so we could debug any of these things. Debug AAA. We should be able to debug all, but this is a simulator, so everything is not going to work exactly the way that I want it to. Okay, I paused there for a minute, fool around with it to try to get it to send us some debug commands, and you can see these things running up. It's hello packets for EIGRP. So yes, we can see, and this is what's actually going on, the sending and receiving that's going on inside the router itself. So the debug command and the show command are the ones. The debug provides details similar to the show command, enables you to monitor processes, events, and this would be if something's not working. We could debug a routing protocol to see what it's doing, if it's actually running, is it exchanging the information that we need for it to do with its neighbors. Debug command continues running based on the options specified until a no debug or an undebug command is given. An undebug UAll is typically going to be the easiest one to do that with. Because sometimes it's hard to get these things in here. You see, they just keep going. So we go UAll, and it's still not U space. It is kind of a can't get it in a word in edgewise, and that's one of the issues that we get into when we get these things going. So I will eventually get it stopped, but we have to give the undebug command or no debug or undebug to get those things going. Verify and monitor once problems are identified and resolved. That important to verify the operation. Did we really fix it? And once we really did fix it, monitor what's going on. And the other thing that we never say is document. Can be verified by checking the flow of the packets, executing commands such as the show IP, show interface, show running config, bunch of things that we haven't done yet, but we will when we're doing labs throughout the entire course. The debug command enables you to monitor the network over a period of time. Log messages generated by the debug command help you determine whether the network is functioning as expected. So the debug, show IP, ping, traceroute, and ARP and TELNET are the commands that we're going to use. So when we talk about troubleshooting tools, the ping, traceroute, TELNET, ARP can be important too, to be sure that if we know what the IP and MAC address relationship should do. We can compare those to be sure that there's not a false or an improper ARP. One of the things that hackers like to do in a man-in-the-middle attack is to tell you that their IP address is the MAC address of the default gateway, so that you actually send your traffic through the man-in-the-middle and they can read the traffic as it goes through. Isolate and document. Either resolve or escalate if we can't fix it, and once we've fixed it, we're going to verify and document. So troubleshooting and troubleshooting tools, a quick look at them, a quick look at a couple of demos that I guess sort of worked, sort of didn't work. So the next topic is configure, verify, and troubleshoot IP addressing and subnetting. Subnetting is a topic, I guess, an area that everybody loves to hate. We'll go through a couple of different ways to do subnetting, and I've got some videos that may be helpful in that area. So hope to see you there.